Hello everyone, this is a very brief summary of proof by induction. On the left I have the steps that you follow in every proof by induction, so they're very general, and on the right I have one example. There are a few different types of problems that you need to solve by induction. One of them is where you have a big long sum and you contract it down to one little formula. Another is of this type here in this example, proving that a certain quantity is divisible by another number, and then the third type is proving inequalities using induction. You will always be asked to use induction. You won't have to be inspired to use induction, and if asked to, and then actually also then you have the proof of de Moivre's theorem by induction, which I have just put up on YouTube as well, so that's in a separate video. So for the steps, step one is that you verify the statement is true for the first value of n. That's usually n equals 1, but if it said, for example, n greater than or equal to 2, then you start off at n equal to 2. So it's just the first value of n, but usually n equals 1. And then step two is you assume that the statement is true for n equals k and write out what that statement is. So you must use the word assume, or else you haven't done proof by induction. And I would say write out the statement in that instance there so that you can refer back to it, because you need to use that assumption in step 3, which is use the assumption from step 2 to prove the statement is true for n equals k plus 1. That's where the heart of the mathematics lies. And then your conclusion is always the same. Over here, step 4, if the statement, you state the statement is true for n equals 1 because you've checked it. Then you say the statement is true for n equals k plus 1, assuming the statement was true for n equals k, and therefore the statement is true for all n in the natural numbers, or if it was, for example, all n greater than or equal to 2 in the natural numbers. Okay, that conclusion is always the same. Now, sometimes when we did proof by induction, I used p values, so like p of 1, check the statement is true for p of 1, state it's true for p of k, assume p of k is true, and then prove it's true for p of k plus 1, and then you draw a conclusion for p of n. So that notation is also fine. You'd literally replace the words, the statement, with p1, pk, etc., etc. Okay, so in this example here, so prove by induction that 8 to the n minus 3 to the n is divisible by 5 for all values of n in the natural numbers. So quantity being divisible by 5 means that it is an integer multiple of 5. So 5 times 12 is 60. 60 is divisible by 5. 60 is an integer multiple of 5. Okay, so the first step is you want to prove that the statement is true for n equals 1. So when n is 1, we have 8 to the power of 1 minus 3, which is 5, which I think we can safely say is clearly divisible by 5. Over here to step 2, we assume the statement is true for n equal to k. So replace n by k, and the statement is that 8 to the k minus 3 to the k is divisible by 5. We assume that to be true. Now in step 3, you want to prove then that 8 to the k plus 1 minus 3 to the k plus 1 is divisible by 5. So take 8 to the k plus 1 minus 3 to the k plus 1. And the first thing you want to do is write it in a way so that you spot the assumption. So I would take those powers of k plus 1 and break them up into 8 to the k by 8 minus 3 to the k by 3, because at least we're closer to seeing 8 to the k minus 3 to the k. Now, we would actually see 8 to the k minus 3 to the k if the numbers that they were being multiplied by were the same and we could factor one out. So I took 8 and wrote it as 5 plus 3. So at this point, you would take the number, and I would write it in terms of the number you want to show it's divisible by. I could also have here said that 3 is 8 minus 5. So take one of those coefficients and break it up into the number 5 and the other number. And in this instance here, the number 5 and the number 8. And that means then we've 8 to the k by 5 plus 8 to the k by 3 minus 3 to the k by 3. So in the right hand side there, we can factor out 3 to get 3 times 8 to the k minus 3, and then we've 8 to the k times 5. This is clearly, the one on the left there, clearly divisible by 5. It's an integer multiple of 5. And then on the right, this is divisible by 5 by assumption. And hence 8 to the k plus 1 minus 3 to the k plus 1 there is divisible by 5. And then you write your conclusion, which is exactly the same as step 4 over there. The conclusion is always the same. The step 1, the assumption in step 2 and step 4, they don't vary a huge amount. You should get a few marks from there, and then kind of the kernel of the mathematics happens in step 3.